So as we look at this example, I think you're asking something from 5.7, question number 6. So form a polynomial function with real coefficients having given degrees and zeros. So since the degree is 4, let's see if I can get this to work for us here. So since our degree is 4, we should have 4 zeros present. So let's let R represent the zeros. Well, if one of the zeros is a complex number, 3 plus 2i, then there's also got to be this 3 minus 2i, its conjugate has to exist. And then the 2 has a multiplicity of 2, so that means there's a 2 present. Since there's a multiplicity of 2, that means there's 2 more zeros there. So that means we do have 4 zeros present. So if we have r's there, then we have to use x minus r to represent our factors. So once we have our factors, then we can multiply the factors out to get our actual polynomial. So our first factor is going to be then this x minus then this 3 plus 2i. And then we're going to have x minus, and we have this 3 minus 2i. And then we have x minus 2. And since there's a multiplicity of 2, that's raised to a power of 2. So that's the factored form of it. So now they want us to expand this out. So the first thing we want to do is we want to bring the negative sign through the parentheses here. So we don't want all these extra parentheses. So we're going to rewrite this then as x minus 3 minus 2i. And then we're going to have this x minus 3 plus 2i. And then we still have this x minus 2 squared. So my first goal is to multiply this trinomial times this trinomial. So we have to use the distributive property to do that. I'm going to use the rectangle as an organizer. So I'm going to make a 3 by 3 since it's a trinomial by a trinomial. So we're going to have this x, a negative 3 minus 2i. We have this x minus 3 and a 2i. So we're going to multiply a trinomial times a trinomial. Apologize for the noise. It's construction going on outside. So what we want to do is multiply this out. So again, if you want to pause the video and work that all out, or just work along with me, you can. So we're going to multiply this x through. That's going to be x squared minus 3x. Then it's going to be 2ix. Then we're going to have this negative 3x, a 9, and a negative 6i. And then we'll have this negative 2ix, a positive 6i. And then we're going to have this negative 4i squared. But remember, I squared is equal to a negative 1. So it actually turns into a positive 4. So we do our like terms will be in these diagonals here. So we want to add the diagonals together and bring down our polynomial. So the c then is we have this x squared, and then negative 3x and negative 3x gives me this negative 6x. Here, the 2ix's and the negative 2x's cancel out. That just leaves me a 9. And then the negative 6i and the 6i just zero out. So it leaves me a 4. So this turns into x squared minus then the 6x plus 13. So this over here turns into this x. Let me get back to the color there. So this is going to be x minus 6x plus 13. And then we're going to multiply that by x minus 2 squared. Let's go ahead and multiply x minus 2 squared out. So x minus 2 squared, we can either use FOIL or the box, or it's a special one. So all you got to do is square the x and x squared. Multiply the negative 2x and double it. That'd be a negative 4x. And then square the negative 2, and that'd be a positive 4. So that turns into that trinomial, x squared minus 4x plus 4. So maybe you'll see where I'm going with this is this should be x squared minus 6x plus 13, and then x squared minus 4x plus 4. That looks better. So you kind of see that I'm going to probably again use a box to kind of work this all out to kind of keep it organized. So I'm not great with organization still, but this should work for us. So the x squared, the negative 6x, and the 13 comes along this edge, x squared minus 4x, 4 goes across the top edge. So then we can start building the inside. So it's going to be x to the fourth, negative 4x cubed, 4x squared, 24x. Let's see here. Yeah, it looks like 24x. And then we have looks like, oops, did that wrong. So what's going on there? Lost track where I was, didn't I? So sorry about that. Let's see if I can make this erase down here. Oops, get back up here. So yeah, try that again on this next row here. So negative 6x times x squared would be negative 6x to the third. That makes better sense. Negative 6x times negative 4x would be 24x squared. And negative 6x times 4 would be negative 24x. Then 13 times x squared would be 13x squared. 13 times negative 4x, so 13 times 4, 52. So it'd be a negative 52x. And then 13 times 4 again would be just 52. So if we identify our like terms, we should see that there's this x to the fourth, and then negative 4x cubed and negative 6x cubed would be negative 10x cubed. And then 13 plus 24 would be 37, plus 4 would be 41x squared, if I'm doing my math right. And then a negative 52x and a negative 24x would be like a negative 76x. And then plus the 52. So that's what we should end up with then, is that is our answer there. So we have this x to the fourth minus this 10x cubed plus the 47x squared minus the 76x plus the 52. So see if that actually works out for us.